All right, guys, so today I'm going to go through how the dishes and tablecloth thing works. So I'm just going to use the smartboard here and I'm going to draw out our tablecloth. And there's our dish sitting on top. And we know that when we pull slowly, the plate moves. Okay, so let's look at the forces acting on the plate. All right, so we all know that one force that is acting on everything in this universe is gravity. So I'm going to draw an arrow going down on the plate that says force of gravity. Now, if in the y, and again, y is up and down here, if in the y only force due to gravity was working on the plate, it would fall through the table. And we clearly know it is not falling through the table, so we know that the table has to be pushing up on the plate in an equal and opposite direction. So that's force due to normal. Now we have to think about what is actually moving the plate. So we are moving the tablecloth. So but we're not directly touching the plate. So we need to figure out what force is actually moving the plate along. The only thing it's in contact with is our tablecloth here. So we know that the tablecloth has to be what's pulling on the plate. So what's in contact with the plate and the tablecloth are the surfaces. So the surfaces are interacting. And we've talked about this the other day, that basically surfaces interacting is friction. So what's actually pulling the plate along is the force of friction. So this is one of the few times where friction is actually in the same direction as the motion, because it's the only force on our plate here. So now let's look at when we're pulling quickly. So here's our tablecloth again. Here's our plate again. We have force due to gravity pulling down, force due to normal, the force of the surface pushing up, and we have a frictional force pulling out here, but it's not enough to move it. So we're going to be, this one's pulling fast. The plate doesn't move. And now we got to look at why. So what we know is that the frictional force is not big enough. So why is that? Why in the first case was the frictional force enough to get it to moving, but this one isn't? And it has to do with the acceleration of the plate. So when I'm moving the tablecloth fast, we have a fast acceleration. When I'm moving it slow, we have a low acceleration. So if we think about, say the plate, I gave this example in the Google form, your plate, so the force when we're moving it slowly is equal to the mass of the plate times its acceleration. So force slow is equal to the mass of the plate, and in the video I said it was a 5 kilogram plate, which is crazy heavy, but that's okay, times its acceleration, which was 2. So 10 newtons. So that means the force of friction had to be 10 newtons. Now, if we look at this scenario here where we're moving fast, force on the plate when we're moving it fast has to be, again, the mass of the plate times its acceleration. And we're going to say the acceleration has to be the same as the tablecloth, because if it's moving with the tablecloth, the acceleration has to match that. So in the Google form, We gave you, it was the tablecloth was moving at 5 meters per second. And it weighs 5 kilograms, so the force would have to be, of course, 25 newtons. Well, frictional force is limited by the interaction of the surfaces. And basically, you can't get enough frictional force to get it this high. So friction is limited. And obviously, frictional force can't get up to 25 newtons. So our frictional force has to be less than 25 newtons. So our plate doesn't move. We don't have enough force to get it to moving at the same rate as the tablecloth. All right, I hope that helped you guys understand what's happening with the dishes and tablecloth.